In this tutorial, we'll look at derivatives using the product and quotient rule. First, we'll compute the derivative using the product rule, and then we'll compute the derivative of p of x using the quotient rule. Now for the first, r of q equals 2q plus 1 all times the square root of q plus 4. That square root we can rewrite as q plus 4 all to the half. When you have roots, it's better to write it as an exponent. Now we have a product of two brackets. Let's call the first bracket A, and we'll call the second bracket B. Then r prime of q, the derivative of r of q, is given by the formula a prime b plus a b prime. So we know what a and b are, and we just need to find what a prime and b prime are. So let's go off and compute these on the side. So if a is 2q plus 1, then a prime is 2. If b is q plus 4 all to the half, then b prime is found by using the chain rule. It's a half q plus 4, and then subtract 1 from the exponent to give negative a half. And then we will put a, b, a prime, and b prime into the formula that we created. So I just want to emphasize what a prime, b, and b prime are. So we have a prime b plus a, and this is b prime. Now in this case, there's no simplifying we could do, but we can draw up a couple brackets, and often when you rewrite it, you would put the coefficient first. So in the second term, I have the half in the middle, but because I'm multiplying those three factors, I can just rearrange it and put the half in front. So that's it for that one. Now let's find the derivative of p of x using the quotient rule. So we know to use the quotient rule because we have, in this case, a polynomial divided by another polynomial. So I'm going to teach you a trick that I use for the quotient rule, and you won't see this in the lecture. I find this to be an easier way to memorize the order of how to perform the quotient rule. So I'm going to call the bottom low, and I'm going to call the top high. Now there's a song that you can sing to yourself, and it goes low D high minus high D low all over low low. So sing it to yourself so that you memorize it. I don't know, just say it over and over, say in your sleep, sing it to the tune of J-Lo, I don't know. Just memorize it, and it will definitely help you when you're performing the quotient rule. So in this case, D high means the derivative of the high, and D low means the derivative of the low. So we said high was 6 minus x squared, which means d high, which is derivative of high, is just going to be minus 2x. Low equals x squared plus 3x plus 5. So d low, derivative of the low, is 2x plus 3. So we have everything we need, and now we can just plug it into the formula. So p prime of x, I'm just going to write the brackets out, low d high minus high d low all over low low, or low squared. So I'll write everything in. Low is x squared plus 3x plus 5. D high is negative 2x minus high, which is 6 minus x squared, and D low is 2x plus 3 all over low squared. So now we've taken the derivative and we can simplify it a bit. So in the first term, we can distribute the negative 2x into the bracket on the left. And in the second term, we can FOIL this. So performing these, we get the following expression on the top. So remember, I want to keep brackets around the terms I obtained when I FOILed because I have this negative, which is also why when you take the quotient rule, it's important that you get the song right, because if you switch things around, then the negative, because it needs to be distributed, will give you a wrong answer. So I'm going to distribute the negative. So I'll have negative 2x cubed minus 6x squared minus 10x. Now minus 12x minus 18 plus 2x cubed plus 3x squared. Again, that's all over low. I can cross out the negative 2x cubed with the positive 2x cubed. And for the quadratic terms, I can combine negative 6x squared with positive 3x squared to give me negative 3x squared. Now for the linear terms, I can combine negative 10x with negative 12x to get negative 22x. And then there's just the one constant, negative 18. So this is all over low. Now we've simplified our derivative, and this completes the exercise.